Today we're going to be with Mike Haskell. My name is John O'Day, and we're here at Advanced Thermal Solutions, coming to you from our labs, thermal labs in Norwood, Massachusetts. We're going to be discussing two different clip types, both the ATS patented Super Grip clip and its effects, as well as a sort of an industry standard sort of general clip that's available on the market. Mike?
Thanks, John. What we did at ATS is we looked at the standard off-the-shelf clip that's in the industry now, which you can see here on the right, and we looked to try to improve it, make it more reliable and more capable design. So if you look at the existing clip here, you can see it's an injection molded plastic frame and an extruded or a forged heatsink. The two in combination form a mechanical attach for the heatsink onto a component, shown here as a mock component in the back. So if you look at the frame clip, you can see that the pressure that is placed on the heatsink to the component is really done by these four tabs, these four plastic tabs, which deflect a bit when the clip is attached and applies downward pressure onto the heatsink. The reason that pressure is so important, of course, is that the thermal interface between the heatsink and the component needs to be kept at a sufficient pressure to ensure that the interfacial resistance is reduced. Tapes and epoxies don't need quite a high pressure as phase change materials are greased to, but as a general rule, the higher the interface pressure, the lower the interfacial resistance is. What we did is we took this frame clip and we tried to, again, improve upon it, and we came in with an injection molded plastic frame clip that you can see here that attaches to the BGA. Instead of using the plastic itself to provide pressure onto the heatsink, we use a stainless steel spring clip, which you can see here. And we use the stainless steel spring clip as deflection to apply pressure because the creep resistance of stainless steel, of course, is much higher than plastic. The stainless steel spring clip that you see here also allows for a much larger deflection range when assembled. And this is important because you can see the mock components here in the background. In actual application, component heights aren't constant. They can range from, say, 2 to 4 millimeters in height. And why this is important is that that component height affects the actual deflection in the clip, both the spring clip and these plastic fingers here. And so that deflection height really determines how much pressure is being placed onto the component. We went with a metal spring clip because it allows a much wider range of deflection distance while still ensuring the adequate pressure needed to hold the heatsink onto the component. So I'll do a little illustration here. What you can see is the frame clip going onto the heatsink. So that's in place, and you can see the four small fingers here that apply pressure from the frame clip to the heatsink. You can see now that that frame clip is installed, and each side here has a small wedge along the side that goes underneath the BGA to hold it in place. The ATS clip installs in much the same way. You have a frame clip that goes onto the component and snaps on. And this frame clip is a little bit different as it has wedges on all four sides that ensure to keep the frame clip in place on the component. One other interesting thing is you can see there's a small horseshoe wedge that's molded into this clip. What happens is, as the stainless steel spring clip pulls up on this horseshoe, it actually pulls it in tighter. The horseshoe here contracts a bit and pulls the frame clip tighter around the BGA on all four sides. And that ensures a really strong mechanical bond between the heatsink and the component. A heatsink is then placed onto the frame clip, and the spring clip is then placed on as well. You can hear that nice click that lets you know that the spring clip is now in the correct place. And you can see it's installed over that horseshoe on both sides. It applies a nice steady pressure to the component. What's nice about the frame clip is that it does allow for deflection over time. So as this phase change or grease material warms and the interfacial distance is reduced, that clip can take up the slack, so to speak, and still apply a steady pressure over time as the material heats up and thins out. So that's a quick demonstration and comparison of the ATS Super Grip versus an industry off-the-shelf design and some of the advantages associated with the Super Grip.
Thanks a lot, Mike. And for more information, you can visit qats.com, that's our main website, or our blog, heatsinks.wordpress.com.